reproductive management and a reproductive physiology course at the undergraduate level. Her recent research has been investigating nutritional strategies in boars and the survival of neonatal gilts. And her title today is Colstrom Management of the Young Gilt. So please help me welcome Kara.
Thank you. Ooh, there's a light there. Thank you, Jenny and Michael, for inviting me to be here today. Similar to Chantel, this is my first time at the Leman conference, so I normally am teaching 2 classes in the fall and can't get away, so this was an awesome semester where I only had 1 class and figured they could make out on their own for a day or 2, so I'm excited to be here with you as well. So I think Dr. Farmer did a nice job of setting up the tea here for me, where she described for us how we get the sows and the gilts to produce more milk and develop mammary glands. And then, it's like, if you create it, will they come? So my talk today will be focused on how do we get the gilts to drink more milk, and what is the importance of that milk in longevity and gilt development, and then how much is enough? And so that's a big question I'm going to leave you with today is I'm going to obviously give you my opinions today, and I tend to do that a little bit in talks, but kind of send you away with how much is enough and how do we start to identify gilts that have had enough milk so we know which ones to select into our programs. So I always like to start these talks with kind of a step back into more of a philosophical perspective. Parental care is something that we ask our animals to do daily for the entire life that they are on our farm. We are developing them to be mothers, and then we are asking them to constantly be gestating or lactating, and then rebreeding and gestating and lactating. And so it's actually one of the most complex things across non-mammalian and mammalian species is looking at the differences in species in parental care. And parental care is consisting of both pregnancy and lactation. And so today, the purpose of my talk is to really focus more on the lactation piece. But lactation is extremely calorically expensive and energetically expensive for our sows. And so having a better understanding of why that is so important and what it really provides to the offspring is needed for us to know why it's so important that we get our sows to milk and we get our females to drink that milk. And so we talk about this in a lot of species. Sorry to put up such a funny Time magazine thing here, but is lactation really worth it for our sows to be doing? And we usually think about the dairy cow as being the most milk-producing livestock species that we have. And if you actually look at the average body weight of a cow and a sow, and you look at how much milk they produce in a day, on a pounds of body weight basis, a sow is producing more milk per day than a dairy cow. So we are really asking our sows to work hard and put a lot of energy into producing milk. And today I hope you can leave with my understanding or my thoughts on why that milk is so important. I'm going to focus predominantly on that first milk, the golden milk, if you will, that colostrum milk that I think is so wonderful. So why is it so important? So I think most of us, we even saw this morning all of the data coming out of PigChamp. So I have taken their data that is free on their website, as she suggested this morning, and looked at Canada versus the U.S. Looked at pre-weaning mortality versus litter size starting from 2004 to 2020 PigChamp data. So I don't think this is new for anybody in the room, but as we are producing more pigs, we are increasing the pre-weaning mortality as well. So I did 3rd grade math. So I looked at what the averages were in 2010 versus 2020 and looked at total born, pre-weaning mortality, and then calculated on a per 100 piglets basis what that means we're doing today. So in theory, 3rd grade math, just from the averages, we aren't able to save them as fast as we are producing them. Now, like they said this morning, we don't go just based on averages. We know, and Jenny started us off this morning by saying, we know the genetic potential is there, and there are some farms that are doing better. And the large veterinary groups here in the room will tell you that we are weaning more pigs. So my numbers here aren't exactly right just based on the average, because some farms are meeting, some sows are really meeting their genetic potential, and we are weaning more pigs to financially make this selection for total born economically valuable. But just to kind of set us up, I think we're at a pretty fine line there on are we able to actually save the number of pigs that we're producing. So mortality is going up, and I am just a big proponent that one of the main things that saves piglets is colostrum. And so colostrum, as we know, one of the main factors or important things that it does is it provides survival for the piglets. So this is my favorite graph that I use all the time of Dr. Bartolozzo's, and it basically shows birth weight here and colostrum intake here. And you look here within this little box where you have under 200 grams of colostrum and relatively light birth weight piglets. And I just want to point out that we aren't even considering the piglets that are less than 1 kilo at birth. So this is what literature actually calls medium birth weight piglets, from like 1 to 1.5 kilos. And if you look in here, we have a very high mortality rate. So 31% mortality rate in those medium to light birth weight piglets that don't drink more than 200 grams of colostrum. What's interesting about this compiled data set is even those medium birth weight piglets, if they were able to consume more than 200 grams of colostrum, their mortality rate actually became similar to those of what we would consider more of the heavier birth weight piglets that have a higher chance of survival. So we're in a mortality rate of only 4%. So that tells me the importance of colostrum. So it's kind of hard to sometimes separate out birth weight and colostrum because we do know that larger pigs drink more colostrum. But if we can get those pigs that are even medium or light birth weight to drink enough colostrum, their chances of survival become much greater. So that's one thing about colostrum that is important, is survival. So I'm going to share this data a couple of times, but the 200 gram cutoff was really established in 2011 as kind of the cutoff for survival, and I could say multiple data sets have reiterated that 200 grams as a cutoff for survival in piglets. So this is just some data from Purdue, but here we see the same thing. Piglets that consume 200 grams or less of colostrum had a 40% mortality rate, and a big drop when you see we drop down to those that drink more, survival goes way up, mortality goes way down. So important for survival. But the big question for me is, when we talk about gilt development, is survival the only important trait? And I think everybody in this room would probably argue that the answer is no, right? So we have to define a little bit about what makes a successful gilt so we can determine about how much colostrum she might need in order to set her on that developmental trajectory to meet those successful terms, right? So everybody in this room might have other things to add to this list, but young age at puberty, maybe high productivity, longevity in the herd, that's very important, especially from the data we saw this morning from PigChamp, right? High PSY, maybe looking at the success of their offspring. So I take this and I call it thriving. So is there a different amount of colostrum that a gilt might need to consume to survive versus thrive? And so I think when we talk specifically about gilts, we really have to focus on thriving. So I come back to this table, and again, I tried to look at some papers that maybe defined something about gilts, if they actually looked at them from birth into adulthood, and see if we could see what were some indicators of thriving gilts or making successful gilts. So for example, one paper in 2016 said that in order to increase stayability in the herd, the pre-weaning average daily gain needed to be greater than 0.22. So again, same group of animals here. If I actually look at where birth average daily gain to weaning hit 0.22, that was somewhere between 250 to 300 grams of colostrum intake in the first 24 hours. So then Jeff Villay, I think everybody in this room is probably very familiar with a lot of the work he did looking at colostrum intake and longevity and things. I'll show a lot of his data today. They had a paper that said the optimization for puberty attainment is going to be an average daily gain pre-weaning of 0.26. So again, just looking at my Purdue pigs here over several studies, where did we hit a 0.26 average daily gain? That was somewhere between 350 and 400 grams of colostrum. So if we really expect a gilt to thrive, if we want her to live, she's got to drink 200 grams. If we want her to really thrive, I'm going to set a cutoff in my mind at about 300 grams or above is where we need to get them to be able to thrive as a gilt. So I have bad animations there. So basically, if we look at the kind of just the percentage of the piglets that were born in our studies that actually meet these, it was about 80 to 85% of the gilts actually get to an average daily gain of 0.22 or above, but only about 30% of the gilts got into that 350 to 400 grams of intake of colostrum. So a lot of the gilts that we might be selecting are probably not getting into that higher colostrum intake range. Back to the DeVillers that started the paper about 200-gram cutoff for survival. They actually took looking at what the piglets that actually survived in their study looked like. So they looked at what they had as colostrum intake, weight gain, and rectal temperature just at 1 day of age. And then they looked at the pigs that died between days 1 and 3, between days 4 and weaning, and those that were alive at weaning. And if you just focus for a minute on colostrum intake, you can see that the ones that actually survived till weaning and maybe were thriving had greater than 300 grams of colostrum intake in those first 24 hours. So just some other data sets that kind of maybe reiterate a need for us to see if we can get more colostrum into pigs. So all of us in the room have looked at gilt litters and big litters, and how do I really know which ones have had enough colostrum, right? It's really easy to identify the very, very small kind of failure to thrive rinky-dink pigs that are probably not drinking hardly any. But how do I know in a big group in a litter that's all kind of nursing and fighting, which ones have actually gotten 300 grams or above? So I don't know the answer, by the way. I don't have any reason. I don't have a way to do that for you. If I did, I could probably retire with Chantel here. But I can tell you some things, some factors that are telling us that we aren't hitting that mark very frequently. So research has shown that for each additional piglet born into a litter, each piglet then consumes 20 to 40 grams less of colostrum. So the sows are not producing more colostrum. As litter size increases, they will produce more total milk because that is stimulated by the suckling of the piglets, stimulating additional total milk or whole milk. But the first milk, that first 24 hours of colostrum production is not going up. So we have sort of a set amount that is now divided by more piglets, which means each piglet is getting less. And so this is, again, looking at some data from Purdue. I've just graphed the minimum intake, colostrum intake in the litter, the maximum intake in the litter, and the average is in red. So as litter size goes up, the average colostrum intake goes down, so we probably know that. I was trying to look a little bit at the variation between the minimum and the maximum as we see litter sizes kind of going up. We don't have very many litters that fell up here in the kind of higher litter size range in these particular studies. But the variation seems to be sort of spread all throughout the middle, so I don't see something like a lot more variation when the litter sizes are getting big, just the average is sort of going down. So we kind of compared the same story here, but looking at a commercial farm with the mash-offs and then again some Purdue data. We always talk about birth weight driving a lot of colostrum intake. So here's looking at birth weight with litter size here. So obviously you can see as birth weight or as litter size goes up, average birth weight goes down. And actually this is a little more clear that the average variation in birth weight also increases as litter size goes up. So our piglets that are coming from very large litter sizes are definitely disadvantaged. And depending on when you cross-foster or move pigs around on your farm, a lot of times the colostrum production is really only those first 24 hours. So we are told to leave our pigs on their mothers, on their birth mothers, a lot of times for the first 12 to 16 hours and not cross-foster until after that. So they are at a really big competition with lots of piglets typically for colostrum, where we may be able to balance out those litters for whole milk consumption later. The colostrum part, we're still at a pretty high competition rate with those pigs. Colostrum intake then here with birth weight, again, I can't make a graph look more linear than that. So a direct relationship there between birth weight and colostrum intake. So again, if I kind of take a minute to put my 300 grams of colostrum and see where that falls on a birth weight category, so what weight of pigs are likely to consume at least 300 grams, I get somewhere here maybe around the 1.3 kilo range. And about 65% of the pigs achieved that 300 grams of colostrum intake or better. And then if I kind of take that 1.3 kilo and transfer it back here to this graph and look at what percentage of a much larger commercial farm, much larger data set, what percentage of the pigs actually were born at 1.3 kilo or better, and I only have about 65% that achieve that. So you can see we have a good number of pigs that are sort of probably meeting the survival amount of colostrum, but for sure are not meeting what I would consider the thriving amount of colostrum. So then we did a study at Purdue to just kind of look at what really happens in a pig, or what could be indicators, since I say I need to be able to look at a pig or find something to measure that tells me that pig hasn't had enough colostrum. So we actually took piglets all of around that 1.3 to 1.5 kilo birth range. And so good birth weights and all similar birth weights across treatments. And then we pooled colostrum from tons of sows actually and made a big colostrum mixture. And then we fed those gilts either 20, 15, or 10% of their body weight in colostrum for the first 24 hours. So we basically simulated a low, a medium, and a high colostrum consumption scenario. So one thing that was a very good indicator of piglets that had not drank enough colostrum was that at 1 day of age, those that had had a high dose of colostrum had a very high temperature. They were regulating their body temperature, and I would say their body temperature was way back above 39 all the time. The piglets that for sure consumed very low amounts of colostrum, they still had not regulated their body temperature up to that by the time that they reached 1 day of age. Obviously, weight gain, you could imagine. So those piglets that were fed very low amounts of colostrum, they had very little to no weight gain. A few even lost weight in the first 24 hours. Those that had received the high dose, or what we would consider thriving levels of colostrum, they were all gaining weight by 24 hours of age. And that weight gain ended up continuing on through day 7. So the high or the low and the medium colostrum intakes, they kind of had a depressed weight gain, and it stayed through day 7. For this particular trial, we had to euthanize the piglets at day 7, so we weren't able to go beyond that in terms of is that a sustained response. But luckily for me, other people have. De Villers in 2011 looked at different colostrum intake categories and went all the way to the end of nursery production and looking at weight gain with different colostrum intakes. And so these two dotted lines here that are kind of separated at the bottom, those are the less than 300s. So again, my thriving 300 and above is probably somewhat right. That we have these two are kind of falling off in weight gain. Those that consume a ton of colostrum, more than 440 grams, are way up here on the top, and you have the other two in the 300 to 400 gram range kind of sitting there just under them. Jeff Valet then went out even beyond weaning or nursery all the way to market. And they used an immunocrit, so a blood sample looking at total protein as a indirect measure of colostrum intake in the pigs. And they have defined high and low immunocrit levels and followed those pigs out and saw that the ones that had low colostrum intake then had lower body weights at market age than those that consumed a lot of colostrum in the first 24 hours. So growth is definitely something that we can use to have as an indicator of colostrum intake, but not something we routinely measure or is easy to really see on the farm. But we do know that there are things in colostrum that mature the gut of the young animal. And so that is probably a good reason why more colostrum intake actually does a lot of work at the level of the gut, makes them a little bit better absorptive animals, and they can grow better. Those actually had lasting effects that went even beyond market age, and when they looked specifically at gilts and how they did as production animals, those gilts that had, this is looking again at those immunocrit levels, so animals that did not consume a lot of colostrum, they had older age at puberty and lower piglets born alive in parities 1 through 4 when they averaged those together. So colostrum intake, in my opinion, starts the developmental trajectory of our gilts. So that first 24 hours of life kind of really puts that gilt on a trajectory of growth, and that's going to lead to other developments that are going to lead to puberty attainment and success as a reproductive sow. So the other thing that's an interesting area of research that I'm not going to talk much about today, but is what else is in colostrum. So colostrum is not just fat and protein, but it has lots of hormones and growth factors that we are really just beginning to understand what their roles are. So if you've followed Bartol and Bagnell's work, it's very, very fascinating. They've coined the term the lactocrine hypothesis, and that is basically trying to find how these hormones and growth factors in colostrum, what they do and what they set that animal up for. And so they've studied mainly two hormones at this point, which is relaxin and IGF-1, and looking at how the relaxin IGF-1 in the sow's milk gets directly to the piglet and what are the impacts that it has. And so on the gilt, they have found that specifically relaxin and now IGF-1 really impacts the development of the uterine glands and sort of kind of sets the trajectory to set up that uterus to be a better organ. So lots of gene expression, lots of cellular changes, and the early development of those uterine glands. I think that somebody could base their whole career, or two of us, on their whole careers on studying what else is in milk and what it actually does for the pigs. If you've ever followed human data at all, so there's a lot of studies that have compared breastfed and formula-fed humans, and turns out we have a lot of differences between us. I am a formula-fed baby, I'll admit it. And so, I'm more susceptible to immune challenges. I'm more susceptible to getting diabetes when I'm older. I had a different growth rate as an infant to 6 months of age because I was fully developed on formula. And so if we kind of take that into our minds, we could see how there's something in milk besides just calories that are affecting humans. But when I think about things in humans that are affecting, would they be important in pigs? It's things like immunity and gut function and diabetes and a lot of the regulations of insulin. Those are all things that are important in pigs, right? So the amount of milk and colostrum that our pigs consumed are doing things that we don't even know. And so I still just am a believer we got to get as much into them as we can. So, what is limiting colostrum consumption by our piglets? I tried to make a somewhat complete-ish list, but I think I've thought of 10 more as we've sat here today. But the one is going to be something surrounding nursing behaviors. So that is what makes a piglet miss a nursing. So that's thermoregulation, your piglets being cold. That is competition, so those increased litter sizes, that's being born later in the birth order. That means you have a lot more competition. Some of those teats are already accounted for by your brothers and sisters, and those late-born piglets have a hard time finding their space. They also might get the shaft and have to use some of the teats that are not as good milk-producing teats as their earlier-born counterparts that get the good ones that are really spraying milk. Functional teats, so I think we have talked a lot about this over the past couple of years, is counting functional teats. We have a genetics company that is with us today that has been selecting for increased teat numbers. And so, we can't just have the teat there. We need to make sure that they're actually producing milk. And so that's another way that we kind of have a decrease in colostrum consumption by piglets. Overall litter characteristics. So if you have one of those sows that Jenny and George have talked about for years, where we have these phenotypes of the low birth weight phenotype sow who produces a whole litter of light birth weight piglets. Those piglets aren't very good udder stimulators. So they don't go up and really nose those teats continuously and constantly ask that mom to produce more milk. So kind of the whole characteristic of the litter can actually determine how well that sow is going to milk. A few other things that maybe are important are looking at what the actual colostrum and antibody absorption is in those piglets. So I don't know if the genetics companies can ever start to look at this or see if we can select on some things, but could we extend like gut closure timing so that there's more time for those piglets to absorb the immune cells of the colostrum? Could we produce pigs that have better absorptive capacities at birth or at younger ages where they could actually take in more of the nutrients from the colostrum? And then someday we have to start talking about the behavior of the sows also. We have some good milking sows and some bad milking sows. I walk sow farms often where the sows are laying perfectly sternal as they're farrowing, or they've been disrupted during the farrowing process and they aren't really allowing those piglets to get access to their udders. A lot of times I see that more in gilts where it's their first time and they don't tend to lay calmly and expose their udder to the piglets for them to be able to come and nurse every 20 minutes. So some of the behaviors in the sows might be something else we can consider. So what can we do with management? So what can we train everybody to do to make sure that they are helping these pigs get more colostrum? So I think if you look at this list, this is probably a lot of the management practices that we've put in place over the past 10 to 15 years, and they were all designed with the idea of increasing colostrum intake in piglets. I don't want to be the negative Nancy, but there's a lot of anecdotal things I hear and not a lot of scientific data to support it. And part of that comes from the fact that a lot of production systems today are doing their own research on these topics and designing their SOPs for their farms based on what they find, but they aren't sharing that information with the scientific community or the academic community, which is neat. So the access to a lot of that data is sort of poor for us to be able to kind of compile. But the few studies that we have that are on commercial farms or are robust in animal numbers and are published don't show a lot of benefits specifically in colostrum intake from changing some of these management practices. Those that do, like for example, there are some papers that show some strategic cross-fostering, so taking the large birth weight piglets off after they've had a little belly full of colostrum and making sure the lighter birth weight piglets get some access to the udder. Some of those have shown to be quite promising in terms of increasing the colostrum intake of the light birth weight piglets. They do come at the disadvantage of also decreasing the colostrum intake of your heavy birth weight piglets. And so some of that has shown where you actually get your light birth weight piglets to grow better and maybe survive better to weaning, but you actually lose some growth rate in your higher birth weight piglets while you're doing that. So what are the trade-offs we're willing to make, and what management practices are actually valuable at an increasing colostrum intake? Most of us probably have seen the studies out of Illinois that just came out a year or two ago looking at drying piglets. Very robust study with 10,000 piglets on commercial farms, dried and not dried. And I was really shocked and sad when the data came out because I thought for sure those piglets are going to survive better by being dried, and for sure they're going to drink more colostrum because they're warmer and they're going to get to the udder faster. And neither of those things proved to be true in the study. The only time that it increased survival in the piglets was if the barn was actually pretty chilly. Then it actually helped to get those piglets to survive better. So we either have something we need to do more, or we have to figure out what, if we're going to put that much labor into drying, which is a very big labor ask, where is its value? And I'm not going to say that every farm hasn't seen value in survival of piglets from drying piglets. But my argument is it that we are drying piglets is the value, or I'm putting more people in the barns is the value, and they have a job to do, which means they're attending more farrowings, they're pulling out more pigs that are getting crushed, and we're seeing an increase in survival from having people in the barn. So the data doesn't show us that drying piglets is really improving colostrum intake. But some of the papers with split suckling and strategic cross-fostering do have some good-ish ideas in there. I don't know of anybody doing a lot of work on supplementation. Direct supplementation to piglets is a huge labor sink, and then also to milk sows to get colostrum. There's lots of commercial products around that, giving them a pump of something to give them a little energy to stimulate them to nurse that have shown some promise maybe in lighter birth weight piglets as well. But most of the data is also only treating light birth weight piglets, and some of those are actually the extreme light birth weight piglets, maybe the less than 1 kilos, when I think our opportunity window is in those 1 to 1.5 kilo piglets to make sure we're getting them going. One study that you've all probably seen by Dr. Flowers was looking at strategic cross-fostering specifically on gilts and longevity and production in gilts. So I was in Dr. Flowers' lab on the years we were conducting this study, and this is really not a colostrum effect. We didn't cross-foster till after 24 hours. So this is actually more of a total milk consumption effect that we saw. But when he looked at, for many years, looked at differences in piglets that were raised in small litters versus large litters. So mind you, this was published in 2008. We actually started these studies in 2005 and 6. And so what was considered large litters then is a little different than today. But we had litters of 10 or greater and less than 7. And so a gilt that was raised in a small litter, she had a 4% increase in farrowing rate and a half a pig increase in number born alive from parities 1 through 3. And I love this data, and I think this is great, but I can't go to a single farm today and say, could you make some litters of 7? Because somebody's going to have a litter of 28 if I have to make a few litters of 7, right? And there's no way those sows have, I know we've added a few teats, but we don't have 28 of them. So I think this is great, and this tells us that more milk is better. And so we still have to just figure out how are we going to get more milk. And Dr. Farmer told it perfectly this morning that we are already limit feeding our piglets by the sows that we have today. If the piglet wanted to be ad lib fed, they will eat a lot more milk than what the sow is able to give them. So how can we get them to drink more? So again, which ones have consumed enough colostrum? Right now, our best indicators that we can actually use would be looking at growth rate or immunocrit. But unfortunately, as is our trouble, to measure growth rate would mean we'd actually have to weigh pigs. Not likely to happen. And to do immunocrit, we actually have to take a blood sample from those pigs at 1 day of age. Also not too likely to happen. So we actually need something available to do this. So most of us have heard the popular term biomarker discovery. So I thought I would just share with you a little bit of data that we've been working on at Purdue in biomarker discovery. So for those of us who don't do biomarker discovery, which is really me prior to 2 years ago, basically, most biomarker discovery focuses on some gene or a protein. So geneticists probably know a lot about this. What genes, is a biomarker of an animal that is able to do this phenotype? And so typically we always look at genes and proteins. And the genome is going to tell you what the potential that animal has is, like all the genes that are there, right? The transcriptome then tells you what might happen. The proteome, or the proteins being produced, tell you what actually is happening in the animal. And now we have what's called the metabolome, which is what has happened in the animal. So these are the end products of all of the genes, and the transcription is the metabolome. So at Purdue, we've been focusing predominantly on the lipidome, which are the fats that are a result of all of the genes and the transcription into the animal. And the reason we've been focusing on the lipidome is because of the price of the assay is only $17 a sample, versus those of you who've ever done genome or transcriptome work, it's about $170 to $200 a sample. So we can get a lot of information about what has happened in an animal by looking at what the end products are at a much cheaper rate. So my postdoc here is in the room today, and Kaylin, when she came with us, she started her project for her master's, and that was to actually look at early neonatal nutrition, and can we find some biomarkers in the lipids of the pigs at young ages and see if we can have an indicator that they're nutritionally related. So we took piglets that we took off their dam right at birth, and we fed them just straight milk replacer. So again, not a pig milk, just birthright milk replacer. So has calories for those piglets to live, but didn't have any of the other good stuff that we would think of in colostrum. And then we took piglets that were allowed to suckle their dam for 48 hours, and we actually took their vaginal cells. So I'm a reproductive physiologist, so I really only care about the reproductive tract. I can also access it from a pig without having to take blood. It's any woman in the room who's ever had a pap smear. We used human pap smear brushes, and we just took a cellular sample right out of the vagina of the pig using a pap smear brush. And so I've really been giving pigs pap smears for about the past 3 years, which is quite exciting. But what we did was we basically looked at what fats were present in the cells of the vagina based on having been bottle fed or drank colostrum. And you can see where I'm not great at all doing heat maps, but here on the right or the left is the bottle fed animals, and here on the right are your suckled animals, and you can tell this is like one of the clearest heat maps. there's a big difference in the fats that are present in the vagina of bottle-fed versus suckled piglets. So we came up with this hypothesis that we knew early neonatal nutrition was important. We knew that it affected the reproductive tract development based on Bartel and Bagnell's work, and we knew that that was predictive of long-term reproductive performance. So we knew that that anterior vagina is very, very related to the uterus, and the uterus was the part of the reproductive tract that Bartel and Bagnell had been studying. And we knew that these vaginal swabs were a very non-invasive method that we could easily sample a lot of piglets. We could also not have to kill them or do anything to get the tissue, and we could then sample animals multiple times throughout their life. So we took that to do a commercial trial and see if we could get any kind of fertility biomarker data or indicators out of a large-scale commercial trial. So we went to a 6,500 head sow farm, and we took vaginal swabs from all of the gilts born at weaning. So not even right around colostrum consumption time, we took them at weaning because we knew that colostrum consumption has a long-term effect. Then we followed all those females through parity 2 and kind of got what we called their fertility based on how many PSY they had up to parity 2. And then we created these fertility phenotypes. So we had what we considered the fertile categories. So fertile animals were either low fertility, we said was less than 20 PSY in 2 parities. Middle fertility was 20 to 25, and high fertility was greater than 26 PSY in 2 parities. And then we had 2 categories in our infertile phenotypes. So those that actually showed estrus and were bred but never became pregnant. And then those that actually never showed estrus and never became pregnant. So we called those kind of our truly infertile animals. And so for this study with limited funds, we looked at only the high fertility and the very, very low infertile animals. And we went back to those vaginal swabs we took at weaning, and we ran the lipidome analysis to see if we could find any differences in the lipids to serve as biomarkers of fertility in those animals. So the infertile gilts, so gilts that were highly infertile, they had higher levels of 3 very long-chain fatty acids, cirrhotic acid, hymenic acid, and nonadecanoic acid. And so we actually look for biomarkers. You have to look at the AUC, or the area under the curve analysis. And when you do biomarker discovery, excellent, good, and fair are designed here at basically just like you're giving letter grades here, right? A's, B's, and C's. So really we were in the C category, so we came out with pretty fair. So in terms of are these actually able to distinguish your fertile and your infertile animals, we got about a C. But fertility is not like a disease state, right? So normally when you're looking at biomarkers, you're saying, does this human have Alzheimer's disease? Can I have a biomarker of that? They have a disease state. So those are very easy to find, and you will almost always find biomarkers that are in the A+ category. Infertility is a multifactorial thing, and so I think we thought getting a C was pretty good. So not many people in this room got C's a lot in their lifetime, I'm sure, but today we think it's actually pretty good. The infertile gilts also had lower levels then of arachidonic acid and DHA. And if you've ever studied a lot about DHA, there's a lot of data in using pigs modeling for humans in brain development and all kinds of things that are important roles of DHA in neonates. And so if you ever go by even human formula today, they are almost always fortified with DHA because of some of those benefits. So we did find our infertile gilts had reduced DHA, so that might be important to find. So basically what these animals have is a buildup of these long-chain fatty acids and the eicosanoids, which are a lot of the hormones that we think about that are built up in their tissue at weaning. And we think that the actual problem is that they have peroxisome dysfunction. And so peroxisomes are the system that breaks down very long-chain fatty acids and makes them into a usable form. And so we actually found a paper that thankfully everybody publishes their supplemental information with all of their data for us to go play with. And so we actually took some data from a 2016 paper that did what we did sort of, and they looked at suckled and milk replacer fed gilts, and they actually studied that uterine transcriptome. And when we studied their data, we found that many of the genes that are regulating peroxisome function were decreased in the milk replacer fed gilt. So colostrum was playing a role in stimulating peroxisomal function. So this basically became the link for us between colostrum consumption and our lipids in the vagina. So right now our lipids were a measure of neonatal nutritional, maybe just the composition of the milk replacers different from the composition of milk. But the bioactive factors, or the things in colostrum that actually stimulate function and gene expression in the body, is altered in our animals. So our low fertility animals, we believe, have bad peroxisome function as a direct result of low colostrum intake. So luckily, the USDA bought into our hypothesis and provided us a grant that we just started this year, where we are going to go through and do a lot of the assays, or raising pigs in different colostrum environments, and look at that peroxisomal function and see if we can actually have some biomarkers of colostrum intake that we know also lead to fertility improvement in gilts. So just wanted to say, nothing that we can do in academia is done without the support of lots of other institutions and government agencies. So, and then nothing that I can do is ever done without the help of the students that are with us in the barn, undergraduates and graduates. So just a big thank you to everybody who supports our work at Purdue. And with that, I'll take any questions.
Thank you, Kara. I'll open the floor to any questions.
I completely understand. Let's be very, very clear. I came in, did this session with a strong belief in colostrum, managed to make me doubt. Yeah, could you go back to the slide on the individual birth weight? That was the Mashoff data. Because how do you measure colostrum? Because later you said I can do birth weight, or the increase in weight, and I can do, well, how did you do it here?
So we used the Viller's calculator, basically. So it's a calculation. Changes in weight in the first 24 hours.
Just a performance test.
So Lowe's, he has a lot. I don't know. My data set is 650 animals, which is actually not very robust, and ours was very, very linear. But I would argue that this is a lot more animals, not quite as linear of a relationship seen there. So different genetics, different management, different amount of people in the barns, we might be skewing that amount of variation around.
During your think it's just a matter of intake. If you are a damaged piglet somewhere in utero or something, and you can't drink the milk, you don't grow, and you don't get the colostrum intake in your data.
Yes.
It is only.
I agree with that. If you're a damaged pig, and the light birth weight piglets physically can't suckle as much or as hard or have as big of a gut to hold it. So they will not drink as much.
And if you're damaged, it makes sense that later in life you do worse too.
You do worse too, yep. I never have the answer either. That's I'll always say that.
All right, thanks for that. We seem to be having some microphone issues, but well, hopefully we'll make this work. There seems to be some microphone competition.
Carrie, great presentation. I'm always fascinated with the colostrum. So my question really related to the quality and the quantity, right? In South, we look at the weight of the pigs as a measurement of the quantity. So how about the quantity, right? When you look at ruminant, they will say bricks and then look at the hemoglobin. I'm always wondering, is that important as well?
Looked at enough enough yet. So some of our recent data looking at quality has shown a lot more variation in total protein, total fat among sows versus some older data. But I don't know if, I've also talked with Chantel a lot. My milking abilities weren't as good as hers, and I had to learn how to do it better. And I'm not sure I use the same assays that older data does in order to evaluate the quality of it. But when we look at IgG and IgA content, for example, that's very important that we're getting enough. So the dairy industry uses a cutoff, what they call a successful passive transfer calf. And no girl gets to go become a cow in the herd if she hasn't had successful passive transfer. And that is a measure of serum IgG in the blood of that calf at 2 days of age or whatever. And if they have a certain cutoff, they know she can be a good cow and she can produce good milk. They'll send her into the system. I would love for us to develop something like that in pigs, but what do we measure and how do we know, especially if we're at a multiplier farm where we are developing gilts to become the moms, what do we measure? And I think IgG, IgA, we've tried to repeat a paper that really showed tried to
Copy that, thank you.
is, I think, also or is pretty variable among cows, but we don't measure that either.
Kara, Mark Storley. Thank you for your presentation. You touched on it, but birth order. Is there a strong enough correlation that even birth order could represent the amount of colostrum intake, such that the first 6 gilts are select versus?
Yeah, I didn't show it today, but there is great data that shows that have less colostrum. It also depends on how long the birthing process takes. So, colostrum production begins right at the birth of the first piglet, and every minute after that, we're going down in quality and we're going down in colostrum, basically quality after that. So the labor
The lapel mic cuts in and out too. Yeah, so this one's
So if you have a cow pairing all over 4 hours of time, well, the difference between the first piglet born and the last piglet born maybe isn't that different. But if you have sows farrowing, throughout the entire day or taking some very extended farrowing time, that those late born piglets definitely are going to be a lot more disadvantaged than the early born piglets.
So one quick question on most multipliers, they're pushing the replacement rate like 70, 75%. So you have a very high percentage of parity ones. Have you looked at the colostrum quality across parity?
We've looked at colostrum production across parity, but I haven't looked at colostrum quality across parity. And so colostrum production is lower in first parities than higher parity sows for sure. So, selection of gilts from gilts isn't always the best.
Yeah, to drive the genetic change, though, they want to have more gilts. So.
I know. I always work against geneticists in some way.
So if I can go back to your question, in terms of amount of colostrum, it's contrary to milk, so is this working?
Hello. Wake up, people. Okay, so in terms of colostrum yield, it's opposite to milk. So the gilts produce more colostrum than multiparous animals. And on the reverse, they produce less milk. But in terms of quality, the one thing I've seen is the immunoglobulins. So the immune protection of multiparous sows is greater, so they would transfer more immunoglobulins to their newborns. So that's what I've seen.
Okay, well, thank you very much.